Swadika, my name is Lakshman Gautam. This presentation and video I am creating for my mini projects for AI subject, and the topic which I have selected is Constraint Satisfaction Problem CSP. Okay, let's begin. What is Constraint Satisfaction Problem? A constraint satisfaction problem is a general purpose algorithm. It has been used in the variety of computer science problems. There are several common problem implementation based on the CSPs. There are some common examples which we find in the different books and in online and even research paper as well. So map coloring problem, applying the different color in the given maps. Sudoku, crossword puzzles, image labeling problems, and the more complex and the real world problems could be constraint satisfaction problem in the system optimization, resource allocation problems. One common example is the traveling salesman problems to optimize the operating the logistic infrastructure to best utilization of resources. With the example which I have put it here, screenshot in the right side is the if we wanted to making the logistic arrangement across the Europe, that could be how we manage those available resources to maximize the throughput and minimizing the cost of operations. So the CSP is built around the three building blocks, or we can three pillars of the CSPs. Those three building blocks are like a variables, domain, and constraint. Okay, let's see what does that mean. Let's continue. If suppose CSP is defined as mathematical quotients, and it is a set of objects or variables which must satisfy the given number of constraints on the defined set of defined problem domain. So here, if it is a set of CSP can be defined as a P, and if it is a set of say is defined as a set, then it is a combination of set where the XDC is utilized or it be present. So where X is a set of variables where it could be one or more variables participate in that problems. That could be x1 to xn, and D is the domain, which could also be more than one, and then that also can be denoted as a d1 to dn, and the set of constant which implies to the subset of variables to enforce or the rules that we must satisfy throughout the solution of the solving the problem and until we reach to the goal state or the solving the problems. That constant could be more than one, then that can be denoted as a c1 to cm. So here in our childhood age, we used to have heard the problems finding the age of the father and age of the son with the different equation. I try to give a simple example on the basis of that. Here I denoted age of the father as a AF and age of the son as a AS, and that is a variable. So this is the two variable problems, and the given constant could be age of the father should not be equal to age of the son if they are biological parents, and AF means age of the fathers must be greater or equals to the age of the son plus 18 years. So what is that means here is the assumption is that someone can become a father after 18 age only, and the age of the father must be greater to the age of the son. So similarly here this is the set of rules and restriction which must satisfy, and the domain could be it must have non-empty value for the both variables, and must be integers and greater than 0. This is one simple example defining those CSPs. Now one more examples, CSP example of the graph node coloring problems, where there are four node on the given graph, and each node is labeled with the 1 2 3 4, and that node each name is a set of variables which I have listed in the V set, where 1 2 3 4. Set of domain is the D, where we try to apply the three given different color, which is red, green, and blue, in the respective above variables in the graphical node. And then the constraints could be the adjacent node which is directly connected to next node should not have same color. So one cannot have same color with the two, and one has a direct connected to every node, then the color what we apply in the first node cannot be in the same color in the other different node as well. So we try to implement in the basic tabular format by using backtrack technique in this table, which I'll be explaining now. So in the initial state, the initial domain, initial state will have a possible colors combination could be that possibly can use for every node is RGB. All color can we can use it. And then in the next step, suppose we selected the red color on the first node, and then the moment we selected the red color on the first node, the possible color for other node will be reduced to only 2, because here the other red color cannot be applied to the other remaining node, because one first node has a direct connection to the every node. And then second steps, we selected the green color for the second node. Then here going from left to right, we selected the second node because all has a two possible values, and we selected the second node here. And then here the moment we selected the green color in the second node, we have possibly only green and blue color for third node, and the blue for the fourth node. Here now again, if we try to go from the left to right and first try to apply the blue color in the third node, and then we reach to the violating of state where the we will be violating the constraint. That because once the blue color is selected before in this state to the third node, it will be impossible to give a blue color in the fourth node, and only possible color for the fourth node is blue color. This is the state where the illegal selections happen, so the constraint is violated. This move we need to, in this state now we go to backtrack, and we try to going back to the conflict state from where it started that conflict. We go to that state and try to resolve from the previous state. Then this state is we no longer can accept because it constraint is not meet with that requirement. Then we first because the possible the number which we should be selecting is because B has a 1 possible and third node has a 2 possible. Then we selected first blue color for fourth node. At this moment we have possible color for third node is blue, and the remaining is same as it is, and the remaining color for the green third node is green. Then we are able to solve this problem by using CSP and the backtracking. The same I have represented in these pictures. Okay, let's continue. So this is the common example which we find across the different books, and I have referred these screens and images from this book which clearly explain in detail explanations of the CSPs, and they have implementation using Pythons as well, which easily I have also gone through this to understand myself. So same thing I have referred here. Here the map of Australia has this territory which we can see, and the part of the variables which we encoded in the form of like WA, NT, Northern Territory or Southern Australia, these are the state names which is listed as a set of variables, and domain is the given set of colors. Constant are the adjacent region must have different choice of colors. So that means the color what we apply in the Western Australia should not be same in the Northern Territory and the Southern Australia, South Australia, because they have a border adjacent to each other. So we must apply this different color, and every province in that Australian map should have some color, which is some color means any color among the red, green and blue, which the implementation of the problem is based on the CSP which we try to solve. Then the actual solution it could be like this. Maybe we can combination of different color, but it meets the requirement that bordering touching state or province not having same color. So this is one real common example which we find in across the different books. Let's continue further. And as we know that the map coloring problems for specific to Australia, the solution space or the problem domain is not that big compared to the problems which is in the Sudoku solver or the even a map coloring problems of if we are trying to draw the different colors in the US state, because US has almost 50 state and 50 state, and if we try to apply the different colors, then it's the possible combination and doing such arrangement is really complex compared to applying the colors in the map of Australia. So depending upon the variables and the constraint, the number of input constant and the variables makes the problems and the solution space how much it complex. So now we go to the Sudoku, as we know, it's a game where we need to fill the digit from 1 to 9 on each cell of the 9 by 9 box, Sudoku board, where we need to meet the requirement that constant that number should not repeat on the same rows and the column, and within the 3 by 3 box which I have highlighted in this blue zone should also meet that requirement that the number should be in the same 3 by 3 box, also should have unique 1 to 9 numbers, should not be repeat anything, and any subsequent next cell or of the each box should also have a same number. So we try to solve this problem. See, the problem space is this, and the solution it could be like this, which I have implemented using my Python program that I'll be showing after this presentation. So these are the steps which we involve. I would say like this is the technically a textual algorithm for CSP. So what we do in this first steps is we will try to isolating the empty cells. Suppose in the Sudoku we will have an 81 cell, and among 81, if in the initial state we have pre-filled with the 20 numbers, then we roughly have a 61 empty cells. That is our real problem domain, not the 81, because 81 number, some of the numbers is already pre-filled. So we already minimize some of the iteration and the searching the numbers that from 81 to 61. That means now this is the isolating, that means we identify the empty cell is the first step, and second is we go for elimination steps, which we define as elimination steps, where we try to list all possible number for the every cell which it could apply. So what does that mean? That means like in this state, if in this particular first row and first cell, where if you see from the row to column cell, only 9 is possible. So the possible cell number for this cell is 9, and possible cell for this cell, possible number for this cell is 4, 6, 8, 9. Similarly, it goes to this 4 digits, and again for this particular 2 cell has a possible number is only 4 and 1. Now we have our problem domain is getting narrowed down. This is the second step. We just try to list all the possible number for every empty cells. That is the based on the constant from the given pre-filled numbers in the our Sudoku problems. And then the third state, we try to see any cell which is having single digits number, which is the possible numbers. If that's so, then this is like we have already reached the direct solve or the direct solution for that particular cell, and then we directly select that numbers. In the elimination steps, we isolate the list all the possible numbers and select any cells which is already having the possible number is only 1 digit, and the directly select. In the fourth steps, we try to choose that number and repeat the second and third steps on every 3 by 3 box of 3 by 3 section of this 3 by 3 section of subsection of the Sudoku board. Then we repeat to that 3 by 3 box of other remaining 9 Sudoku board subsection of 3 by 3 box cell, and we repeat these steps until we fill all the numbers unique numbers between 1 to 9 on the every empty cells of the given Sudoku. So I'll show you this my implementation using Python. Same algorithm, same techniques in the subsequent video and after this presentation. Let's continue further. This is the screenshot of the same implementation which I have run and solved the 3 different Sudoku, and I kept it same thing in our presentation. And now this is one common example where CSP implementation is done using the integer or the linear programming using Lingo. This Lingo is one software where also we can put different objective functions and set of constant, and it solve the equation by using, we can solve this equation by using Lingo. So this is the Lingo model where we can define these first lines where you can left side this Lingo model optimization systems. This is the equation 3x1 plus 5x2 is the optimization objective function. Objective function, it could be maximize or minimize, depends on our requirement, and the set of constants are this. The moment we have entered this syntax in the Lingo, and if we have a correct syntax, it will solve the problems. The problem which I try to solve is this first 1.1 problems. The value for that solution is 4,6 is the correct value, which gives the maximum value for this equation, which at the end of the presentation I'll show you in my implementation on the Lingo as well. Let's continue further. And if the because CPS implementation using graph also possible, this is we can say the integer programming where if the problems or the variable participating, that the problem is only two dimension, where we can visually plot and see what is happening in the paper. In that case we can solve the problem by using plotting also. This is the one assignment which I have done in for my subject in optimization. Same thing I have kept it here, and the same solutions problem domain I'm trying to define here. Now here is a one thing which I want to highlight is that here this is the problem is a minimization problem where the equation is z equals to x2 minus 2x1. We should get the best possible minimum value for z. This is the objective function and the set of constant we have defined. The constant which is very critical here is the last constant, which is which says that x1 and x2 must be greater than to 0, greater than or equals to 0. If that constant not there, so now this is the solution which we can see in here. This shows that 4,0 is the value for x1 and x2 is the best minimum value by satisfying all the constant. But if that last constant, if we don't have negative constant of that x comma x, that could be negative value also could be possible, then the actual minimum value that we get it for above equation, we'll get it at 10.5 comma minus 6. That means with this solution we violated one constant. So during the solving the problems as well as until we reach to the solution from the start to goal node, we must satisfy the given constant. So then the actual solution for this problem is 4,0. Now let's continue further, and this is the one real one and the really complex problem which I'm trying to solve for my other subject in the my subject in optimization. These problems is one example. This data which I have extracted from one of the balance sheet of the one bank of Nepal, and this applies all across the world. Any bank will have similar instructions and the set of rules which I'll explaining now. So this problem says that this is the data I collected from the balance sheet of that particular bank in 2018. Of that data that I have got it from that 2018 balance sheet. So that says the interest on for that particular year is this amount, and the fund available and the available fund for the next year to lending is these are the amounts which depends on the different category of or the loan type to diversify the investment from the bank. So here two things are very critical here. The interest rates what it makes the banks to income. And when the bank lend the money to the some customer, these they earn from that interest rate. Then that when the everything is going good and the well, then everything is going well, then customer is paying and repaying the loan. But there is a possible cases, some cases the customer get defaulter, or the customer is no longer is able to pay their loan. In that case, the defaulter ratio for the personal loan, here real estate loan, every loan have its own probability or the percentage of failure rate. So where here real estate loan is a defaulter rate is 2%, and the personal loan is 5%, agriculture loan is 6%. The rate in the personal loan and the tourism loan and manufacturing interest rate is higher, and it has a similarly it has a higher defaulter rate as well. So the more the risks, of the more the benefit, there could be more risks as well. So this is the one set of examples. Now if we say that if the bank wants to maximize their interest income throughout the year, then the problem of constant objective function, it could be like this: 98% of real estate loan into 12%. This acts is a real estate loan amount. It could be some amount which is we have listed here. Then that could be into 12% minus 2% of 2% of that is a failure. So this is the total earnings from the that is the possibility of after subtracting that defaulter rates, this is the possible of getting the good income. Similarly, it goes here 95%, and then same thing we can see here across the each category of the loan for diversifying their investment across the different 5 set of the loan type. We know that a bank normally will have more than this category. I try to minimize these problems to still 5, but that also really complex here, because the constants, as we know, in the central bank of the every country will have some rules to mitigate the economics problems associated with the every financial transaction is happening across the country. So some regulatory requirements, rules are like which I have highlighted here, regulatory rules which I have put it why. Here it says that personal loan total investment or the total lending amount in the personal loan category should not be greater than 10% of total loan funded amount. And the another constant is sum of manufacturing and the tourism loan cannot exceed beyond the 60% of total fund. And it could be lesser, or it can go up to 60%. Similarly, real estate loan must be less than or equal to the 25% of total loan funded amount. And other constant is like suppose some sectors is not that productive, and the bank says that I may not invest on bank people may say that we may not invest in that sector, but country or the central bank wants to equally distribute or diversify their investment. So that what is the biggest constant here is bank cannot say I will not invest in the some sector, like I will not say invest in the tourism sector because it has a high default rates. But there is a minimum requirement is every category of or every sector of loan must be minimum 5% of their total loan funded amount. So these are the set of constant. Now we can see we have 5 variables and there are 9 constant. The problem domain is become really complex here, and I try to solve these problems. I'm still trying to solve the problem using first I try with the Lingo, and Lingo is not able to solve the problem because it says the infeasible solution space, because it's not able to solve that problem because it has a more number of variables. And I'm still searching and trying to figure it out how I can implement this in the genetic algorithms or in linear programming. If anyone has some suggestions, I'm happy to hear from you all. Please give me some feedback. I wanted to implement this for my midterm projects for the optimization as well, just for informing. But I presented this is also one real examples of CSP. That's why I presented. Okay, let's continue. Now this is my presentation, and I'll try to show you my implementation using the Python and Lingo. Let's go here back to the. I have implemented the Sudoku solver program by using the Google Colab, and let me open. This is the Google Colab code structures which I have implemented, and this is the same algorithms which I have explained earlier in the presentation, and this is the problem which I have shown here. Actually, if I'm here, this is the same problem which I have listed there, and solution I copied from there to my code to here, same thing. Now let's go here, we'll try to execute. This is just an example how it solve the problem and how it what is the input. In input we take the number from 1 to 9 on the pre-filled cell, which normally we'll have in the Sudoku, and those empty cells I put it 0. I selected 0 because the possible legal numbers in the Sudoku is 1 to 9, and 0 is not a valid number, so then 0 is the empty state of that particular cell. After running my program, it printed output like this, and which solves the problems. Now let's go to execution. So first step, we take the input here and it's just printing. We are not doing anything here. I define this method to print, and I printed input array, and this is the I run this, and here we have as I have explained, 3 critical algorithm steps which we need to follow. First is the isolating steps, where they find the empty cells. This method helps me to identify all the empty cells which has a 0 in the value. That means empty cells, right? If it is greater than 0, then it will not mark as empty cells. That gives the empty cells, and that passes to that cell will be passed to these 2 methods, Sudoku solver and validation of selections. What does Sudoku solver does? Every backtracking techniques or any recursion problems, if we want to optimize, normally recursion is much more efficient than the normal looping or something techniques. So recursion means it's that methods calls by itself. So Sudoku solver calls Sudoku solver until it satisfies some conditions. That condition will be matched with these validation steps. Validation steps does that 3 steps. What does it does is that I can tell you now from here. So first it checks the checking the number, anything what we are trying to enter is on the row by row basic, and this section checks in the column by column basis, and this section checks the section by 3 by 3 box. 3 by 3 box within the 3 by 3 subsection of the Sudoku, which is 9 3 by 3 sections will be there within the given Sudoku. So this is the implementation. Now I will go from the implementation to running. This is the input I given, and first I copy the dip clone copy of the input array so that it will not modify the reference, and it will make the input array damage, so that I can print it. Then I run this. Here this is the input array, and the solution space is here, which same thing I have put it on my presentation slide also. If you remember here, the same thing I have explained how the 4 1 and this 9 is eliminated in the first step itself. Same thing, it's the same Sudoku problem, and it's solved within the 20 millisecond, less than a second, and it's pretty good. And I try to solve the another problems, another Sudoku. This is also different input, and it solve it. Similarly, I try to run here, and it solve this. For the second and third steps, I didn't keep the measurement of the time, because the time which we can clearly see that which is printed is very fast. So I didn't printed that logic where I need to calculate different amount calculation logic here like this, which I have not kept it. So now this is what I have implemented. This Google Colab source code I'll be sharing in the GitHub, and I'll share this link along with the video which I'm going to upload. And now let's go to the Lingo, which I have explained here. Lingo, by using Lingo, the same problems which I'll be showing now. The same constant which I have put it here. These are the constant. This is no, this is the constant, and this is the objective function. So our objective function is to maximize this, and it should be every instruction in the Lingo should be terminated with a single semicolon, and these are the constant, and that constant after end we should put some keyboard end. This is not case sensitive, we can keep the capital letter as well here. Once we have a correct syntax here in the Lingo, after that if we click here, this will give a detail of execution. Here it says the model class, what it uses linear programming, and objective function, objective is 242, and the more details are here. The total variables are 2 variables, and the constants are 7 constants are there, and non-zero values are 10 in the along with the constant and the input equation. And the memory what it uses is this. So it gives the basics execution summary. Now we can see here, this is the value what it have calculated. X1 is the best value is 4.00, and x2 is the x2 is the value of 6. This shows that this is the implementing the solving this kind of equation by using Lingo. And that's all from my side. If anyone has questions, I'll happy to answer. This Lingo program and my Google Colab source code and presentation, as well as this recording video, I'll be uploading in the Facebook, and I'll share these details. Thank you so much for listening me, and thank you so much, and be safe, stay home. Thank you.